Welcome everyone to this IOSH Hazardous Industries webinar. Glad to see so many of you with us today. Really appreciate it. In this particular webinar, we are going to be looking at alternative warehouse solutions over fire sprinklers and how you can use hypoxic warehouses in your processes. So I'm really glad to be joined by two experts in this field. I'm sure they don't mind me going and calling them that. My first one is Brian Gouldsworthy, who is the team lead for fire safety and incident management at AstraZeneca Macclesfield. Brian has worked in the pharmaceutical industry for more than 30 years with ICI, Zeneca, and now AstraZeneca. And prior to that, he was in the Royal Air Force. In addition to his fire safety role, he's also responsible for COMA or Seveso, emergency plans and compliance, and delivering training to responders at operational, tactical and strategic levels. He has a particular interest in the factory of the future and the fire protection of warehouses which contain large automated storage and retrieval systems. My other speaker today, Carl Bryan, has 30 years of experience working within the UK fire and security industry and has spent the last 10 years specialising in fire prevention systems as a managing director of Wagner UK Limited. He holds an MBA from the Wolverhampton University Business School and is an influential member of numerous working groups within the Fire Industry Association and British Standards Institute. So thank you very much, both of you, for joining today. If you could go and put your videos on and give people a little wave, let them know we're here.
Good afternoon.
Okay.
Hello, everyone.
As we continue on, if you want to go and ask any questions at the end to Carl and Brian, we'll go and have about a 10-12 minute little Q&A session. So please put that into the Q&A box. So thank you. Over to you, Brian.
Thanks very much, Nigel. So I am going to talk about hypoxic fire prevention, but I'm going to take you on a learning journey that I went on a few years ago and found myself looking at these systems, looking at automated storage and retrieval and looking at protection for them. So it's kind of my little learning journey I'll take you on, if I may. Okay, I shall stop my video and we'll continue. So there we are. We'll start with this one. This is AstraZeneca at Macclesfield campus. So we are the big triangular bit in Cheshire. So it's an important site for us. We produce medicines, very important medicines for heart disease, lung disease, cancer, diabetes. And we are the second biggest manufacturing site in the AstraZeneca network. So very important, very big, lots of people around and lots of issues for us. We are also a COMA site. The banner at the top is our protection strategy. So we start with that for everything we do, everything I do. So whether it's writing emergency plans or whether we are building a new facility or changing a facility, I'm looking at this strategy. This is our functional requirement. So it goes a bit further than building regulations. So protection of people, I am thinking of our staff, our emergency responders from within the company on site, the external emergency responders. I'm thinking about our neighbours, and I'm also thinking about our patients. So if we were to have a fire and we get everyone out and everything is good, but we lose the asset, we can't produce the medicines. So there is a patient on the end that I need to think about. Second, and this is in order of priority, second is the environment. So releases to air, to ground, and particularly water. So today we're thinking about contaminated fire water. If we think, we are a COMA site, so most of our scenarios, as you would expect, are to do with chemical reactions. But we have a couple which are MATIs, major accident to the environment scenarios. And one of them is from a large fire in the warehouse, activating sprinklers, calling the fire service, putting more water on, washing the water out into the river and causing harm, resulting in a MATI. I'll come back to that towards the end. The A is for the asset. So again, we have to think broadly and holistically about the asset. So that is the bricks and mortar and the steel and the concrete, but it's also the activities, the operation, everything that we do in that facility, because it's linked to our business and to our patients. And an element which is often missed is reputation, which is really important for all businesses, particularly for pharmaceutical businesses. So if we protect people, the environment, and our assets, doing the right things in the right way at the right time, we will protect our reputation. So that's our functional requirements. And again, I'll probably revisit that as we go too. Just click on when I can. So taking us back a few years to around 2014, in the red box you can see is our traditional low bay warehouse, which is a big warehouse, basically 3 fire compartments, large compartments, traditional racking, in-rack sprinkler system with ceiling protection. So the business decided that our packing lines needed to be upgraded. We want to be kind of world-class and state-of-the-art, so we need to build a new facility. And the business decided that we would build this new packing facility inside that warehouse. So the first phase of the project was to empty out 2 of the fire compartments to make room. So stage 1 was to build a new warehouse. So we built a high bay, and that's the bit we're going to talk about today, and its protection. So it's in there, it's a fully automated operation. So it's operated by cranes. People do go in, but generally it operates on its own. It's really big. It's very important, and we're putting all those materials into the one space now. So it needs some protection. Back then, our designers from WSP said, they showed us the plans and said, how would you like to protect it? And we kind of went down the standard route, and we thought, well, we'll have sprinklers, because we all know sprinklers, we all like sprinklers, and we have a long history. We know them from the last 130 years or so. And they said, have you considered a hypoxic fire prevention system? And we hadn't. So I say we, there's a small team of us looking at this. We had to learn about this system very, very quickly, because this project was motoring on. So that was our question, that was our problem, and the start of this learning journey. So let's have a look. So I'm looking for evidence now and seeing how these systems operate, what the challenges might be, and what the options are for protection, and what the evidence is. So we always need evidence. We always need to challenge. We always need to test. We always need to check and verify. So I'm starting that piece of work. So these systems are not the same as ours, but they share a lot of the same characteristics. So on the left, you can see this as an auto store system. You might recognize these, seen them around. They're really good, very smart, and they can be really big. This one stands on the left about 6 meters tall, about 16 boxes in there. These are the plastic totes, and the robots run around on the top picking the materials. On the right is Ocado, which is a very similar system. Operates in the same way. This one is the Andover factory, and you can see it's sprinklered. It was given the highest protected risk award by FM Global, so we know the sprinkler system was a good system to the right standard. As I say, these are not the same as ours, but they share these same characteristics. So low occupancy. People do go in there for certain activities, but operates on its own most of the time. High density, which is really good for businesses. They're typically 4 times the density of traditional storage. So you can get lots more materials in there. But of course, your fire load goes up. There's a lot of material in this. And there's quite a bit in the system itself. High fire load, high fire growth rate. Now that's kind of debated. I would say it's high fire growth rate. Others say that it's not. Others will state that these are slow fire growth. And the reason they give is that these systems are so dense that there isn't enough oxygen. But I would argue that there's plenty of oxygen, and we'll see. You make your own mind up. They are generally high value because they're very big and they're very important to businesses. And they're very dense, automated, and challenging environments for the fire and rescue service. So if you imagine going in here, committing your crews in if you're a fire and rescue service, challenging, difficult. We'll now have a look at one of these running. I can move on again. Just having cursor troubles here. There we go. So I'll set this one running. This is the one you've just seen. This is the Andover one. So they're very good. This is about the size of a football pitch, and there are 2 of those in the Andover unit. And the robots run around on the top. They've all got lithium batteries. At the time, they had plastic caps on them too, which have been removed. But you can see they run on rails. You can see how big these systems are. You can see the top row of boxes. So you're actually looking across the top of the grid when you look at these systems. But if you imagine you've got maybe 16 boxes, 20 boxes underneath, and these robots dig them out. I'm just messing around with my cursor again. So you can see how challenging that would be if there's a problem in there. And it was this one that had a fire. If we can switch over. There we go. I'm going to go on a bit. There we go. So back to 2019, there was a fire on that grid on the right. So there was a fire in one of the robots, and the fire spread from the lid. I think it was a kind of battery fire on top of one of the robots, spread to the plastic lid and then spread down into the grid. At one point, the sprinklers did activate, and so that the fire was kind of took hold, and the sprinklers were actually isolated at some point by the staff. So we need to have a look at why they did that. But on the day, there were no staff injured in this, so they could see it, and they responded and they evacuated. 200 firefighters spent the night tackling the fire. 4 firefighters were treated for minor smoke inhalation. There were firefighters actually committed onto the roof of this, and they were quite a long way on the roof. So again, we're looking at the impact on people. We're taking some risks, so we have to think, what are we trying to achieve? How much risk are we taking, and does this make sense? So there was potential there. The fire did break through and the roof came down, but nobody was injured because somebody gave a shout and they all got off the roof in time. I believe there are other firefighters committed inside and trying to cut holes in the structure and get to the seat of this fire. There was a 500-meter exclusion zone around the site, so there was some impact on the people who lived close by. And then there would have been impact on people's jobs as well, because this facility was lost. If we look at environmental impact, there was actually a report into this fire by the Fire and Rescue Service. It wasn't a good report. And I think this was a landmark fire, and I think there was a lot to learn from this one. And we seem to try very hard not to learn the lessons. The report did not present a timeline. It didn't ask certain questions. It didn't provide a chronology. And something it didn't mention at all was the environment. So we know that from other sources that 10 million litres of water were put onto this fire and foam. And most of us will be aware now that there are issues with the foams that we've been using with PFAS, and some of it is restricted under the POP regulations, PFOA, PFOS, and there's, of course, exposure to the fire service in this too. Persistent and toxic in the environment. So we have to think holistically again about what we're trying to achieve and what the risks are. The asset was lost, so the asset itself was about 110 million. And then on the reputational side, Ocado shares dropped by 6% on the day, or kind of around that day, which was around $1.3 billion, which they've recovered because they're a very good and smart company. But we need to think holistically about these things. There we go. So that's what it looked like. If you're going back again to committing firefighters onto roofs to put these fires out, to do your final extinguishment. And the chief said it has been very difficult. That's with these new systems and working at height, and they're not really designed for people to be in there. They're not really designed for firefighters to be in there. And this was, so I'm watching this fire and this commentary. So the day after, the director of the FPA came out and said, and I'll read this out, although the majority of sprinkler operations result in a fire being extinguished, their design remit is to stop the development of a fire, hold it at manageable size, and support fire and rescue service intervention, ensuring structural integrity of the building and supporting tenable conditions for a predetermined period of time until it's manually extinguished by them. So it's very interesting and worth remembering that that is the design remit. With the increasing size of building complexity of internal structures limiting access within the building and the potential for fire seats to be at some height, there may be a need a review just to review just how effective fire and rescue services can be expected to be within the sprinkler system design framework. So for me, when I'm reflecting on this, we're asking a lot from the fire and rescue service. As a business, we're asking a lot of them. So we put sprinklers in, and that's the first half of the plan. The second half is manual extinguishment, generally by the fire and rescue service. So it's asking a lot to have them put themselves at risk to extinguish these types of fires, deep-seated, very dense fire load, and actually long travel distances too. This person then went on to say, it could be that sprinkler systems played their role effectively. Without sprinkler systems, surely everything would have been on the ground in a day. So I'm starting to see kind of a pushback against the recognition that there might be limitations to sprinkler systems. And there are limitations to all of our systems. They all have to be appropriate to the risk. But we really like sprinkler systems. So the traditional narrative is they are the answer, and you can't really say anything to degrade that. But for me, it's just data. So I'd say if you're going to burn it to the ground, do it in a day. Don't do it in 4 days. And then you have all the firefighting, the risk, the contaminated firewater. So again, continuing the journey on and looking at for evidence, I found some tests, or this particular test from FM Global. So this is not the same as Ocado, it's not the same as AutoStore, it's not the same as our own high bay, but again, it shares certain characteristics. So this is a large-scale fire test using open-top combustible boxes, and we see how sprinkler systems, which are very effective with standard commodities, struggle with these systems. So I'm going to play this one, and I shall move it on a little bit in the interest of time. I shall set this play in and move it to about there.
The same 195 gallons per minute or 740 liters per minute per sprinkler. At time 0, the igniters are lit. At 4 minutes and 25 seconds, flames can be seen above the top storage level, and at 4 minutes and 30 seconds, the flames are almost up to the ceiling level. At 4 minutes and 35 seconds, the first sprinkler operates, and the flames are quickly driven down the rack to the lower tiers.
Fire's being knocked down.
By 7 minutes and 36 seconds, the fire has moved away from the operating sprinkler towards the end of the rack and grown vertically back to the top of the rack. The fire involving the first 3 tiers of storage is burning freely.
Eight minutes, 5 seconds, still one active head. Ceiling temperatures have increased.
At 8 minutes and 12 seconds, another sprinkler operates and at 8 minutes and 25 seconds, an additional sprinkler operates well away from the main rack. The fire continues to spread towards both ends of the rack. The fire involving the bottom 3 tiers of the rack is not being controlled by the ceiling sprinklers. By the end of the test, a total of 8 sprinklers operated and the fire burned to both ends of the rack. If the rack was longer, the fire would have continued horizontally, resulting in more ceiling sprinkler operations until the water supply would be overtaxed. So here we had a similar product consisting of an uncartoned, unexpanded plastic, but the sprinkler protection design that was used in the standard uncartoned, unexpanded plastic commodity test failed to stop the spread of fire within the rack. The difference, in this test, the sprinkler water was being collected in the combustible open-top containers and was not allowed to flow to the lower areas of the rack where the fire was located. It is well known that plastic storage can produce severe storage fires. You might be wondering if open-top corrugated containers present the same challenge to a ceiling sprinkler system's ability to control a fire. In this demonstration fire, 2 rack arrays are set up side by side. Each array is under a single quick response sprinkler. The storage height is 15 feet or 4.6 meters, and the ceiling height is 30 feet or 9.1 meters. The left storage array consists of the FM Global standard carton unexpanded plastic commodity with no open-top containers. The right storage array is identical, except the top tier of storage is replaced with an open-top corrugated container. The single sprinkler over each array will deliver a flow of 159 gallons per minute or 600 liters per minute, which is more than adequate for cartoned unexpanded plastic storage at this storage height. Starting at time 0, both arrays are ignited.
Okay, at 5 seconds, the flame heights are at the top of the first tier. Both arrays look fairly consistent. Top of the second tier, 15 seconds. Over the top of the third tier, 18 seconds. On the
By 30 seconds, the fire in both storage arrays are above the top storage level. The sprinkler over the cartoned, unexpanded plastic commodity rack operates at 33 seconds, and the fire is quickly driven back down through the rack. At 44 seconds, the sprinkler over the rack with combustible open-top containers on its top tier operates, but the fire is not as quickly driven down into the rack.
Down to the first tier level, and some flames at the base of the second tier, spreading laterally.
At 1 minute and 15 seconds, the fire in the rack without combustible open-top containers is mostly located in the first tier with some flames in the second tier, while the fire in the rack with combustible open-top containers is fully involving the first and second tiers of storage. At 4 minutes and 40 seconds, you can no longer see any fire in the rack on the left, while the rack on the right with the combustible open-top containers is now fully involved in fire. As was obvious in the video, the left rack was quickly suppressed by the single sprinkler. At 4 minutes and 41 seconds after ignition, fire cannot even be seen in the left rack. However, the rack on the right continues to burn. Finally, the majority of the right side storage array is consumed. The only difference between these two fires is the presence of combustible open-top containers on the top tier of the rack on the right side. The series of tests discussed in this video clearly demonstrates how combustible open-top containers prevent water flow from ceiling sprinklers from getting to the fire, resulting in a significant challenge to ceiling-only sprinkler protection. The use of combustible open-top containers significantly impedes the water flow. In addition, the combustible open-top container construction material does not change the hazard.
Okay, so it would seem that open-top containers are the nemesis of sprinkler systems. If had that been a standard commodity, those sprinklers, ceiling-only sprinklers, would have no trouble in controlling, suppressing, and probably extinguishing those fires. But the introduction of open-top boxes is a problem. So if you go back to the Hazardous system and the AutoStore system and some of the other systems you'll see in large warehouses, we use lots of tote boxes. So they will collect the water. The water, I think that some of these mechanisms are the same. So I'm looking to see, well, why didn't the sprinklers work in the Ocado? Because they were switched back on. The report doesn't say that, but they were switched back on. And they ran for the full duration, 4 hours, and 850 cubic meters of water, plus what the fire service were putting on, and the foam, 10 million liters. So why wasn't that adequate? But we can see here the water is collected. The water doesn't get down. It's not pre-wetting as it might do. It's not suppressing as it might do. The heat is in some of these systems, the flue spaces are closed. So again, if you think about the Ocado system, the AutoStore, the robots are actually running along what would be your flue spaces. So the flue spaces are there for the heat to go up and activate your detection and suppression. And then the water uses the same flue spaces to come down to pre-wet and suppress. But again, that's all impacted, potentially impacted. We need to think about these things. But one of the other things I saw as well a little while ago is we changed from wooden pallets with slats and openings in them to solid plastic pallets, again, which we like because they're very good for good manufacturing practice. They're very durable and they're easy to keep clean, but they present a solid surface again. In-rack sprinklers shouldn't have a problem with them, but if you're ceiling only sprinklers, then they might present a challenge. So we can see there, these are some stills from those videos we just saw. And this, again, this is interesting for me, and I'm looking at our protection strategy, people, environment, assets, reputation. So firstly, I've got a fire. The fire is easily lit and spreads very quickly. So that's a problem. The second photograph is the smoke. So we call it smoke, but it's flammable gases, toxic gases, soot. So that's a problem in our warehouse as well. So if we have a fire in the warehouse, that would be a problem. It would write everything off. If we have smoke and soot and toxic gases through there, that will write everything off. Then we activate our water. And this looks nice and clean because it's a test facility and run quite a lot. So that would be a problem. And write everything off. And then it's steam. Our sprinkler water is generally not as clean as that when it activates. And then, of course, the last one was the fire. So there are some issues there. And I think with sprinklers, I'm not really going to achieve my functional requirements here. The last thing that the commentary said was the construction material does not change the hazard. So it's going to help. And I believe the newer systems are not using so much plastic in their totes, in their boxes. They're going over to metal boxes, which is great. And that's definitely going to help. But they still have all the materials that are stored in them at 4 times the traditional density. So the fire load is still high. And these boxes will still capture the water. So it does not change the hazard. Continuing on with evidence, I found that there have been quite a lot of tests subsequent to this, but when I was looking back in 2015 time, I was finding this. So there were some tests done on the AutoStore sprinkler, on the AutoStore automated storage and retrieval system. And they carried out their tests and tested them with ceiling-only sprinklers because that's all you can do for these systems. You can't put an in-rack system in, there's no space. And they activated their systems, and then they went in afterwards with, in red here, it says, firefighting after completion of the test was undertaken by activation of a separate water deluge system over the array combined with crews with handheld water nozzles working from scissor lifts. Crews use traditional fog jets and with foam injection to create non-aspirated low-X foam, which they were finding was more effective. But if you go back to these big systems, there is no access for your fire service. Or now we are starting to create access for them. So we're still going to send people in. We're still going down this manual route, and we're still happy to expect the fire service to put these things out for us. So we're going down the suppress, contain, and then manual extinguishment route. So that was Underwriters Laboratories in the States, then more tests at RISE in Sweden, suppressed but not completely extinguished. Fair enough, it's a suppression system. Small residual fire was not discovered until the grid was dismantled. Fire regrowth was observed when the water supply to the sprinkler was terminated. And then we went off to Underwriters again. Final extinguishment was achieved by firefighters that directed hose streams directly into the burnt openings of the array from above using scissor lift type and boom lifts. So they're not available on these systems. Test array needed to be manually dismantled from the side of the array to get water to the seat of the remaining fire. So now they're taking it to bits and burrowing their way in. Something that I originally missed and went back and reread. Here, a small fire was not discovered until the grid was dismantled. Fire regrowth was observed when the water supply to the sprinkler was terminated. In this test, in their lab conditions, they thought the fire was out and they isolated their sprinklers. And I think that's probably what happened at Ocado, is they thought their fire was out. They thought their sprinklers had done their job because they're looking across the top of the grid. They see fire, then they see water, then they see steam, and they think they're done. But we've seen in the other fire tests that it can be deep-seated and spreading down and spreading sideways. I'm happy for someone to tell me I'm wrong if you have evidence. And that's what these tests look like. So they were quite big tests, but still not as big as the real thing. So this is 5 meters by 5 meters by 6 meters high. And these tests were summarized by saying, verification tests show that sprinkler protection of AutoStore storage systems is viable even in facilities with very high ceiling heights. overall, test results were considered very successful. Now, I look at the same evidence and I don't see success, but we can convince ourselves because maybe that's what we want to see. Evidence is evidence. So, getting back to our topic eventually. So there is another way, and it looks a bit too good to be true. So how about no fire? No fire, a fully automated operation and fully automated protection. No manual intervention required. So this is us back to our warehouse. That is our warehouse being built and in design. So you can see it's similar. It's a great big block. It's pretty big, 45,500 cubic meters, 30 meters tall, 60 meters long. Very good, very impressive. There's lots of these going up around the world, and some are much bigger than this one. The value is high. Now, again, well, I appreciate I'm talking to IOSH, so we know about the hierarchy of control. So I would suggest that prevention is first, then extinguishment, and then suppression. So I will try to remove the hazard where we can. So we can't always do it, but perhaps we can in this situation. Right, I'm going to play a video. This is the system we have. It's the Wagner OxyReduct system. I have no connection other than we use this system to Wagner. We have an alternative system in our Swedish site, but this explains much better than I can how it works.
Centralized high bay warehouses with complex automated operating processes. Logistics companies all over the world are worried about fires endangering their time-sensitive delivery obligations. We've asked ourselves, how can we protect our goods from fire, smoke and soot, toxic gases and heat? A conventional sprinkler technology would not meet these requirements. The water intended to extinguish the fire can cause serious damage to the product, as well as to the technical equipment in our warehouse. And that's why we decided on an OxyReduct system. OxyReduct, the idea behind action rather than reaction. The active fire prevention system minimizes the risk of fire from the outset. Fire needs fuel, heat energy, and sufficient oxygen at the same time. The system's principle is based on lowering the air's oxygen concentration in the warehouse through controlled introduction of nitrogen. This puts the protection level below the ignition threshold of the prevalent materials. Sensors and the OxyControl control system monitor the oxygen level in the protected area to ensure that the oxygen concentration is continuously maintained at the specified level. The nitrogen will be produced on site and on demand and is introduced into the protected area by pipes. The inert gas nitrogen can be distributed homogeneously and displaces the oxygen present in the room air. For cardboard boxes, the ignition threshold is 15% oxygen volume. With the safety margin and measurement tolerance, the target concentration in the high bay warehouse is therefore 13.6% volume. And it works. Enough oxygen for people, but not enough for fire. The required nitrogen is extracted from the ambient air on site in an energy-efficient manner by our OxyReduct system. It generates nitrogen by separating oxygen and nitrogen with the help of active carbon. While the active carbon binds the oxygen of the compressed air in the CMS tanks, the nitrogen is released into the protected area. The OxyReduct system's performance can be adjusted flexibly. It saves on installation space and eliminates the need to keep a supply of extinguishing agents on hand.
Seit etwa einem Jahr ist unsere
Our oxy-reduct system has been in operation for around a year. Was that the right decision? The answer is obvious. An attractive investment, transparent operating costs, and maximum safety for our goods.
und die höchste Sicherheit, die man sich für seine Ware wünscht.
But protecting our staff was also a major consideration, of course. Despite the high degree of automation in our warehouse, we need to make sure that our colleagues can enter the protected areas safely at any time, without any danger. Medical studies have confirmed working in an oxygen-reduced environment is no hindrance to humans at all. Athletic activities at great altitudes demonstrate that a healthy person can handle lower oxygen concentrations. We want to deliver on time, and our processes have to function smoothly to do so. After all, customer satisfaction is what ensures our position on the market.
Oxy-Reduct.
And that's precisely where oxy-reduct helps us. The system protects our goods and safeguards our logistics processes. Wagner, as German quality manufacturer, constructs oxy-reduct systems and is a partner for its customers from the very start. Consulting, planning, project work and
There we go. So that's the system we have. We've been operating ours for about 5 years now. And our system is set at 14.9. So we achieve that by taking a representative sample of our materials, our typical materials. We send them off to Wagner for testing. They test them. They show us the test results and they video them and send them back and make the recommendations. So ours operates at 14.9%. So normal air is 20.9, so we're dropping it 6%, which is still okay for people. So it's all right having a system which prevents a fire, but we still need to go in there and we still need to be safe. And interestingly, this kind of goes against what we've learned for many years, because we say at 19%, our air monitors alarm and tell everyone to get out of an area. And we're saying, well, don't worry about that. We're going to take you a bit lower and you'll be absolutely fine. So it kind of goes against what we've been learning. So 14.9, we're actually doing some more testing at the minute, and we may even raise it a little bit further just to reduce the load on the system and reduce maintenance. So you may be wondering what it's like to go in one of these protected spaces. Normally, when I do these presentations, and I've done a few, I will take half a day on site and we talk about it, present, discuss, and then we go into the high bay. So I've been in there with the fire service, I've been there with insurers, I've been in there with the Hazardous installations group. And I asked if anyone has experienced a low oxygen environment before, and some have, and some think they haven't. Some have been up mountains and some have go skiing and doing different things. But we find that everybody has experienced it, just about, because everyone has been on something like that. So that's the Airbus A380, biggest airliner in the world, and 850 people travel on this one. And when it takes off, when all aircraft take off, you get to 2,500 meters. The air is expanded in the cabin and will be at around about 15%, which is the same as our high bay. That's when the aircraft is pressurized, and they will hold it at that 15% for your entire journey, regardless of your altitude. And they don't tell you about it. There are no medical questionnaires, and everyone is fine. So you're sat in your seat and you're okay. But the staff are working and looking after you in the cabin, and the guys in the pointy end, they're on 15% too, the equivalent of 15%, and they're fine. So we do this all the time, and we don't really know about it. So going back, and I am just about the end of the presentation, so I will go back and revisit our, sorry, I've just got pop-up on the screen, revisit our functional requirement again. So we have a system here which we can have no fire, no smoke, no steam, no contaminated firewater. And one of the matties that we had, we have engineered out now. We don't have it because we are not using water to put fires out. So we got rid of the matty from our warehouse. No intervention. So we're not expecting our staff and the fire service to enter our warehouse to put our fire out when there is no life risk. The system prevents fire. And back to our strategy. Did we achieve our functional requirements of our strategy? People, environment, assets, and reputation. And I shall stop my presentation there and give someone else, maybe give Carl a chance to speak. There we go. So I'll come out and put my video on and say hello again. Hi, Nige.
Thank you very much, Brian. Really appreciate that. I think we've gone and got some really fantastic questions to pose you and Carl. So I'm hoping you're ready, Carl. I think you really answered one of them right at, just at the end there, going and talking about health risk associated with working in a hypoxic environment. Now, as you said, you've gone and invited the IOSH Hazardous Industries group along and showed us the entire high bay and let us in, which was lovely.
Yeah.
But do you require any specific certifications or qualifications for individuals in your hypoxic warehouses?
There are requirements because the HSE regard it as a confined space. Even though it's absolutely massive, it is largely confined and they say it has a specified risk. So the specified risk would be asphyxiation. Now, I could push back on that and say there is no chance of asphyxiation. The risk is hypoxia, low oxygen, not asphyxiation, which is kind of unconsciousness and death. The thing about our high bay is we know the conditions. There are no unknowns. The entire atmosphere, in terms of its temperature, its humidity, and the oxygen, is monitored and engineered to be as it is. And if it goes out of spec, we know. If I ran my system as fast as I couldn't push it below 14.9 if I tried. So we know the system. I do accept it's a confined space, even though I could argue that it's not. As a confined space, we need reasonable controls to go in. So there are some really dangerous things in the high bay. And the ones that will really do you some harm are a fall from height and the cranes. So they have to be interlocked. So we have to make sure it's safe for people to go in. The risk from the atmosphere is just hypoxia. It's being low in oxygen. And you'll know yourself, and you could probably attest that, well, did you notice any difference? I go in, I check, I test. I take people in, I take pulse oximeters in, I take oxygen monitors in, I test at different heights. I've been 30 meters up with it. I've been to each corner and just to see it's all the same. So check and test. Don't trust me, check, test, come and have a look. But as far as medicals, you need to be reasonably fit to go in. So we talk about the MET system, metabolic equivalent of task. So it's like the Glasgow Coma score, if you're familiar with that. It's a global system. I've put all this evidence through people who know much more than I do. So I put it through our site physician, and he's discussed it with our external service providers, our external physicians. We've used the best of the information that we've got out there, and there's some really good stuff from the mountaineering community. They talk specifically about this. So basically it says if you can walk up a couple of flights of stairs, carrying 11 kilos, if you can run, if you can, do similar things to other people without becoming out of breath, then you're okay to go in. So there is a requirement, but it's just reasonable fitness.
Good. Thank you. Good answer. I think this one's more for, I think this one's for both of you. It's a really, really good question, because if you've gone and switching over to this type of a warehouse, you've got low occupancy, but isn't the cost of operation going to be higher? And then how did you sell this to your management compared to a traditional warehouse? So I know it's two questions. We've said, I know the answer already because we've talked about it before, but I think people will be really interested in that particular answer to that question.
Yeah, there are. Sorry, Carl.
No, you get it.
So there's many benefits over sprinklers. So there's a whole range of these, and we don't have time. But one of them is that the installation is much easier because a lot of it is, well, it came prefabricated. We plonked it down on a raft and plugged it into our HVAC system. All the sensors are at low level, so you've engineered out working at height to, as you would need to with a sprinkler system. It does use electricity, so you need to think about where you get that from. And so that there are kind of savings on the costs of installation, saving on the time of installation. You don't need things like smoke vents, so those are out, although you will need airlocks. So some of it swings and roundabouts. If you're interested in carbon, then there's a lot of carbon, embedded carbon in the steel of a sprinkler system, typically about 2 tons per ton of steel. So you can kind of look at all of these different elements. But again, coming back to our functional requirements, sprinklers would not give us the protection that we needed. So there are sort of financial benefits. We can run it for quite a long time before we hit. Somebody I know had a similar system. They ran their system. They worked out they could run their system for 15 years before they hit this cost of sprinkler installation. That was just him and his site.
I think if I can just add as well, I mean, normally when we're involved in a project, we're involved in a project because the client is building an automated warehouse. That's the decision is to build it in that way, and actually building it in that way creates a problem in terms of I can't protect it in the traditional way using sprinklers. So it doesn't tend to be I want to build a warehouse around the oxygen reduction system, if that makes sense. It tends to be a byproduct of the way that the building's being built.
Thank you very much. Let me just go and grab a few more questions here. Just go here. Could there be any applications for explosive environments or ATEX rated systems? Is there any examples of that you know about within this area?
I'll take that one, if you like. So the systems are generally applied to fires where we're going to have a sort of slow growth, incipient type scenario. We look at each application and really, delve into the specifics of it. So it may be you could apply it and it would help, but it may not provide complete prevention, I would say. And similar, I can see there's a question on lithium batteries, similar kind of scenario there. You in terms of lithium batteries, thermal runaway, I guess most people on this call know, once that happens, there's very little to stop that happening. But it can help in reducing risk, but not necessarily providing the prevention that Brian's got in his warehouse.
Okay, thank you very much. I think you've already answered the requirements of the UK confined space regulations in your discussion, unless you want to elaborate any more on that, Brian.
Not really. When we were told, well, the regs it doesn't really conform to the regs in terms of a confined space because it doesn't have a specified risk. The HSE said it is, and we're quite happy to accept that it is because it doesn't cause us any troubles because the controls we need to put in place have to be put in place anyway because of the fall from height and the cranes. We just need to make sure people are reasonably fit to go in as far as the hypoxic atmosphere, which is fixed, and we monitor and we control. Okay.
Thank you. for Carl here, are any of these systems used in IT server storage areas?
They are, yeah, they are. And that's where the history really of these systems came from. So if I go back 10, 15 years, the systems were used a lot in place of to give a better level of protection than a gas extinguishing system. I think what we have seen over the last 10 years is a move towards fresh air cooling in those environments. So whereas if you went to a data center typically, say 10, 15 years ago, you would see the warm air just being recirculated and cooled. And then the thinking moved on to say, well, actually, if the air's colder outside than it is in here, why don't we just filter that air and bring it in because it's free? We don't have to pay to cool it. So that has changed the applicability, for want of a better word, of oxygen reduction systems to data center environments. But again, we do, that is an area we work in. And if you have critical data, then obviously the criticality may lead to wanting prevention.
Okay.
Yeah, just on data centers, it's something I'm looking at the moment, is that we put gaseous systems in, and they are really standard and nobody questions it. But when you put one of those systems in, you've effectively created a confined space.
Mm.
So you'll need probably better controls than you would with a hypoxic system, certainly equal to.
Okay, thank you very much. Another question. How are nitrogen hoses positioned to ensure nitrogen saturation at that lower levels within the machinery of the high buildings?
So I'll take that one. Yeah.
Mm-hmm.
So again, in the design, we'll look at what the airflows look like in a particular application. So if we've got good airflows if it's a cold store, we've got a refrigeration system, as long as the redundancy on the refrigeration system is as good or better than the oxygen reduction systems, then we'll piggyback on the back of that airflow. And the nitrogen outlets you won't need many of them within a space like that. If we've got a warehouse that's got no airflow, working on one at the minute that's to a passive house standard, so it's very, very tight and there's a very little airflow in there, then we may have, and in that instance we have several levels of outlets, and a more extensive number of outlets, but it'll be far away from a sprinkler pipe work. It's sort of 2 levels and 2 runs of pipe work. So yeah, but it needs to be considered in the design.
Good. Because we're coming up on time, I really do appreciate the two of you going and coming on and presenting on a different solution to normal fire prevention technology that we're all grown up on and we know very, very well. So fantastic. What we will do is any of the questions that we've got outstanding, we will go and submit them to Brian and Carl and go and put it onto the LinkedIn page for the IOSH Hazardous Industries group. I really wanted to just get everyone to thank the two of you for your time and the fantastic presentation. And I wanted to just go and say, hope you all have a very pleasant weekend. So thank you for joining us.
Thank you all.
Thank you.
Thank you.